Um, Hi. This is the Mystery Molecule Project. Um, Me and Maddie worked together on it, and I'll be doing the first half. Okay. So the gene name and location is Homo sapiens phosphatidylanoacetal. Glycan anchor biosynthesis class A. PIGA is also another name for it. Then it's also lesser known as GPI3 PNH1 PIG-A MCAHS2 NEDEPH. The location is chromosome X P22. The locus gene with protein product, protein coding genes. The protein may be predicted of an unknown function. The disease associated is paroxysmal nocturnal hemoglobinuria, PNH, diagnosed after flow cytometry test, a test used to analyze characteristics of cells. That's how you kind of confirm that. Symptoms and signs: acute myelogenous leukemia, aplastic anemia, blood clots, death, hemolytic anemia, which are red blood cells being destroyed faster than made, iron deficiency anemia, and myelodysplasia. Blood making cells in bone marrow aren't working. And then this is just an image basically of kids who are born with PNH. And here you can see the difference between the normal and mutant alleles right here. Yeah. Patients above the age of 65 are at a much higher risk of getting PNH. Patients that are also obese, have diabetes, or have high cholesterol are at a greater risk of the disease as well. People with PNH can be expected to have just as long a life as people without it if they receive treatment. Although there is a treatment for this disease, there isn't a cure. The treatment for patients keeps your condition under control and stops the disease from progressing and causing serious medical issues. Pregnant women with this disease face more health risk, and their fetus is at risk and may not develop. So this is the mutation. The main mutation is PNH. This mutation is caused by an X-linked PIGA gene involved in the first step of synthesis. PNH can arise in the setting of a bone marrow disorder such as aplastic anemia, MDS, PMF. Yeah. 6 exons are present in the wild-type gene, and the mutation will have less due to exons being deleted from the transcript. And then, oh, sorry. I don't know what that. Yeah, so that was just a quick video, and then here's the transcriptions of mRNA, and that is me.
Hi, I'm Maddie and I am doing the second part of this presentation, so here we go. So there's a total number of 6 exons in the PIGA gene, which is also the wild-type gene. There are 3 present exons in the mutated PIGA gene due to the deletion in the mutation. So when the mutation happens, DNA sequences are being deleted, which then lowers the number of exons present. And then, so there's a total number of 5 introns in both the wild type and the mutated gene which I found when I was researching and studying this, which I found very interesting, because you would think because there's a deletion happening there would be a lower number, but not for this one, it stays the same. So exons are termed nucleic acid coding sequences, which are present in the mRNA, and introns are the non-coding sequences present in the hnRNA, which are removed by RNA splicing before the translation. So the protein product, the mutant differs in the 5N UTR. It lacks a portion of the 5N coding region and uses an alternate start codon compared to the variant 1 type. The resulting isoform has a distinct and shorter N-terminus compared to the wild-type gene. The wild-type gene encodes for 484 amino acids. Once the deletion happens, the genes make for only 448 amino acids because the mutation took out a good chunk of them when the DNA sequences were deleted. So the function and structure. So for the wild type, the gene encodes for a protein required for synthesis of the GICNAC-PI, the first intermediate in the biosynthetic pathway of the GPI anchor. The GPI anchor is a glycolipid found on many blood cells and which serves to anchor proteins to the cell surface. Peroxisomal neutral hemoglobinure in an acquired hematologic disorder has been shown to result from mutations in this gene. Alternate splice variants have been characterized also in this gene. It's located on the chromosome 12. So the mutation, in vitro functional expression studies in the Piga null cell line showed that the R412X mutant protein retained some residual activity with partial restoration of the GPI anchored proteins, suggesting that it is not a null allele. The mutation can affect the structure of the protein by causing the protein to malfunction or not produce at all. The Piga gene typically has a deletion in the mutation, meaning that the DNA is being deleted from the transcription, messing up the total structure. So without the DNA being present, you won't have a full structure. Disease mechanisms. From the mutation, the protein structure is affected and changed. The mutation causes a disease called PNH, which affects the process of red blood cells breaking down. So in this mutation, your red blood cells are struggling to break down like they are supposed to, because in normal bodies we are able to break down white and red blood cells, but this affects that, and meaning you can't break them down.